Hello friend, welcome to Concept Undergo Civils, where today I talk about the limit state of collapse shear. Limit state of shear. In my last video, I talk about the limit state collapse compression, where I discussed all the assumptions. So today in this video, we'll share some codal provision regarding limit state of shear. Hope you understand. So without further delay, let's get started. So this whole shear concept comes under clause number 40. Okay, so first we talk about nominal shear stress. If you want, then you can play this video within 1.25x or 1.5x. Okay, so what is the nominal shear stress? The nominal shear stress in beam, that is the tau v, that is vu by bd, vu by bd, where b is the breadth, d is the effective depth. That means, suppose this is your cross section, it is b and here the reinforcement, so this is your d, effective depth. Vu, that means the shear force due to design load. So from where you find this? Suppose this is your beam and in here live load, imposed load is acting. So what will be the reaction? This is W by 2. Suppose this is L. This is W Newton per meter. So this is also WL by 2. And what is the shear force? WL by 2. WL by 2. So that is the maximum value WL. So here VU should be WL by 2. Okay. I hope that will be clear for you. And one more thing, this nominal shear stress, this formula only for the mention here uniform depth. So uniform depth means that means suppose this is your beam, everywhere, every place the depth should be d. It is not less than d, not greater than d. So what happened if shear for non-uniform depth? First, let's once again. First understand what is non-uniform depth, where d is variable. Here d is constant. Here d is constant. So d is the variable. That means diagram should be this, where everywhere the value of d is changing. Okay, so in that case the shear value tau v equal to vu plus minus mu by d tan of beta by bd. Same, b is the, I mentioned here, b is your breadth, d is effective depth, and m is the bending moment due to design load. So in that scenario, what is the bending moment? The bending moment should be this WL square by 8. So here m, that is equal to WL square by 8. Okay, now what is the tan beta? Here beta equal to the angle between top and bottom edges of the beam. That means this is top, this is the bottom, this angle that is equal to beta. Okay, I hope that will be clear. Okay, but why we use the negative sign? The negative sign formula apply when the bending moment increase numerically in the same direction, effective depth d increase, and the positive sign when the moment decreases numerically in the direction. So that moment increasing this direction, d increasing this direction, then negative sign will be there. D decreasing this way, moment decreasing this way. In that, so we use positive sign. Now we talk about design shear strength of concrete. That is the 40.2. What? Design shear strength of concrete. For this, we have to refer table 19. Table 19, design strength without shear reinforcement. This is your table 19. This is your table 19. Here, how we find the tau, and this is this symbol is tau c. Unit should be Newton per mm square. How we'll find? First, we have to find 100 AS by BD. Here, AS means area of steel, and same B equal to breadth, D equal to effective depth. So from 100 AS by BD, we find this value, and then we find the grade of concrete 15, 20, 25, 30. So within this, say 100 AS by BD, our grade of concrete is M25, and 100 AS by BD value is 0.75. Then what will be tau c max value? What is the tau c max? Now M25 and here 0.75. That is 0.57 Newton per mm square. In case the value is 0.95, in that case you have to interpolate between value of 0.75 to 1. This is how you have to find this. I hope now it is clear. Now we talk about if shear for solid slab. In that scenario, one multiplying factor is coming, that is the K. This K value is giving for where depth of slab 300 to 150 or less. Then K value should be 1.0 to 1.3. Suppose your tau c value should be 0.57 and depth of slab is equal to your 225. Then K value is 1.15. Then K into tau c should be there 1.15 into 0.57. This is how you have to find out the design shear strength of concrete for solid slab. Okay. Here they are saying the shear strength member for axial compression. This is the formula, but I have never seen in coming in examination. Then we talk about the main thing, another main important thing, 40.2.3, that is shear reinforcement. Okay. For understanding shear reinforcement, we have to refer table number 20. In table number 20, we have to find out maximum shear stress. Maximum shear stress. Say M25 is 3.1. Okay. And now understand gradually. When tau v means nominal, is less than tau c. Tau c means shear strength of concrete. say tau v equal to 0.1, tau c equal to 0.5, definitely less than. Then this is the case number 1. No need of extra shear reinforcement, just provide minimum shear reinforcement. Number 2, if tau v less than tau v greater than tau c max, but tau v less than tau c max. This is case 2. In that scenario, we have to provide shear reinforcement. That is saying the 40.4, and that equation equal to Vu 0.87 Fy ASV d by SV. For effective depth, ASV means area of stirrup. SV means space between stirrup. But if this is for vertical shear reinforcement. But what happens if inclined stirrup? For inclined stirrup, you have to use Vu equal to same 0.87 Fy ASV d by SV sin alpha plus cos alpha. Alpha is the angle of inclination. Alpha is your angle of inclination. And this alpha not less than 45 degree, and Fy always 415 Newton per mm square, and not be greater than this. And d effective depth. But if case number 3, this is not mentioned, but I am saying here, case number 3, tau v greater than tau c max. What happened? Section should be redesigned. Now here they are saying about the shear strength section. So you can go through, but I have never seen. So this is all about the shear provision in limit state method. So where I discuss formula, how to use all the formula, how to refer the tables 19, table 20. I hope that will be very much clear for you. But if you have any kind of doubt, definitely do comment in comment section. I will definitely get back to you. And if you find some value from this video, then share with your friend, to enrich their knowledge, because knowledge is one thing that is help you any places, and that can help you to survive. So yeah, thank you for watching this video. See you in the next video.